Suppose we have a function that goes from some domain D to some codomain E. So there are a couple ways that that such a function can be problematic. So if this is our domain D and here's our codomain E, and f is some function, so some way of assigning values in E to things in the domain in D. So in this diagram, each dot represents some item that's in the domain or some item that's in the codomain. So f is basically some collection of arrows that tells you which item in the codomain is assigned as a value to each item in the domain. And when everything is working nicely, it might look something like this. Okay? But there are a couple ways that a function could be problematic. Okay? One way that a function could be problematic, so again, my domain is on the left and my codomain is on the right. One way that a function could be problematic is if there is one output that has more than one input that goes to it, like this, right? So this is a perfectly good function, but it turns out for some purposes having two inputs going to the same output is sort of troublesome. So one thing that we might want to do, one thing we will do, is investigate what does it mean, or what is special about the situation where this doesn't happen. Well, if this doesn't happen, that would mean that every input is sent to a different output, and so we'll give this name a property so that we can sort of study what it means. And the name that's given to this property is such a function is called one-to-one. Okay, so this function is not one-to-one. This function up here is one-to-one because every input gets sent to a different output. Okay, but there's another way that a function can be problematic. So what if we had something like this? Okay, well, in this situation, the thing that you might notice is that there's an item in the codomain, this one right here, that doesn't have anything that goes to it. That doesn't make this not a function. This is still a perfectly good function, but there may be some situations where this sort of missed item in the codomain might be a problem. So what we can do is sort of make note of when this doesn't happen. The name for functions where this doesn't happen is called onto. So a function is onto when every item in its codomain gets hit by something. Okay, so I'll put quotes around hit. Right, so this isn't onto because there's an item that gets missed, right? So an onto function would have essentially every dot in the codomain has an arrow that points to it. There might be more than one arrow, so this would still be onto. It wouldn't be one-to-one because there's something in the codomain that has two arrows pointing to it. But this is onto because every item in the codomain has something pointing to it. So what we'll do is we'll look at what sort of properties linear transformations have when they're either one-to-one or onto.